Our guest today is Karthik Hosanagar, a professor of technology, digital business, and marketing at Wharton. And we are speaking with him about his recent book titled A Human's Guide to Machine Intelligence: How Algorithms Are Shaping Our Lives and How We Can Stay in Control. Karthik, welcome to Knowledge at Wharton. Thank you so much for speaking with us today.
Mukul, thanks for having me here. It's always a pleasure to talk to you and the Knowledge at Wharton crew.
Thanks. So these days there's a growing buzz about artificial intelligence and machine learning, and quite a few books have come out recently on these topics. In all the conversations that are going on, what do you think are some of the points that are being overlooked or not sufficiently emphasized? And how does your book seek to fill that gap?
Yeah, clearly there's a lot of buzz around AI and machine learning, which is a subfield of AI. I think the conversation tends to, either glorify the technology or in many instances lately create a lot of fear-mongering around it. And, I don't think the conversation has focused on, what's the solution, how are we going to work with AI, and especially in the context of making decisions. And so my book is focused on making decisions through intelligent algorithms. And certainly we have various kinds of AI. But one of the core questions when it comes to AI is, are we going to use AI to make decisions? If so, are we going to use it in a decision support way? Are we going to have the AI make decisions autonomously? If so, what can go wrong? What can go well? And how do we manage this? Because we know AI has a lot of potential, but I think there will be some growing pains on our way there. And so those growing pains is what I focus on. How can algorithmic decisions go wrong? And how do we make sure that we have control over the narrative of how technology impacts the decisions that are made for us or about us?
I'd love to come back to the part about decision making and algorithmic decision making. But I really love the way you began the book with some very striking examples about chatbots and how they interact with humans. I wonder if you could use that illustration to talk a little bit about how human beings interact with algorithms and what some of the implications are.
I began the book with a description of Microsoft's experience with a chatbot called Xiaobing. In China, it's called Xiaobing, and elsewhere in the world, it's called Xiaoice. This was a chatbot created in the avatar of a teenage girl. And it's meant to engage in fun, playful conversations with young adults and teenagers. And this chatbot has about 40 million followers in China. And the reports say that roughly a quarter of those followers have said, "I love you" to Xiaoice. So that's the kind of affection and following Xiaoice has. So inspired by the success of Xiaoice in China, Microsoft decided to test a similar chatbot in the US. And they created a chatbot in English, which would engage again in fun, playful conversations and targeted once again at young adults and teenagers. They launched it on Twitter under the name Tay, T-A-Y. And this chatbot's experience was actually very different, and it was very short-lived experience as well, because within an hour of launching, the chatbot turned sexist, racist, fascist. It tweeted very offensively and said things like Hitler was right. And Microsoft shut it down within 24 hours. And later that year, MIT's Technology Review rated Microsoft Tay as the worst technology of the year. And that incident, opened up this question for me, which was, how can two similar chatbots or pieces of AI built by the same company produce such different results? And what does that say about, our decision to use algorithms for a lot of our decisions in our personal and professional lives? And that's what helped start this exploration into use of AI, the extent to which AI can be predictable, biased, as in the case of Microsoft Tay, and then, of course, what does that mean in terms of using these systems to make significant decisions for us.
So why did the experiences differ so dramatically, and is there anything that can be done about that?
One of the insights that I got as I was writing this book, as I was trying to explain the differences in behavior of these two chatbots, was actually from human psychology. So psychologists describe human behavior in terms of our nature and our nurture. And so our nature is our genetic code, and nurture is our environment. And so psychologists will attribute problematic issues like alcoholism partly to nature and partly to nurture. And when I was looking at algorithms, I realized algorithms have nature and nurture as well. So the nature for algorithms is not genetic code, but the code that the engineer actually codes in or writes. And that's the logic of the algorithm. The nurture for the algorithm is the data from which algorithms learn. And so increasingly, as we are moving towards machine learning, we're moving from a world where engineers used to program the end-to-end logic of an algorithm, would actually specify what happens when any situation happens. If this happens, you respond this way. If that happens, you respond a different way. And so it used to be all nature because the programmer gave all the very minute specifications of how the algorithm will work. But as we move towards machine learning, we're kind of telling algorithms, here's data, learn from it. And so nature starts to become less important and nurture starts to dominate. So if you look at what happened between Tay and Shawwise, the difference is in terms of their training data in some ways. And in particular, in the case of Shawwise, Shawwise was created to mimic how people converse on Tay. And so it was picking up how people are talking to it, and it would reflect that. And so there were many intentional efforts to trip Tay. And so there was nurture there as well. And part of it was nature as well, meaning that the code could have specified certain rules. The code could have specified rules like do not say the following kinds of things or do not get into discussions of these topics and so on. So it's a bit of both. And I think that's what, in general, rogue algorithmic behavior comes down to.
That come back a little later to the whole question of why algorithms go rogue.
Yeah.
But I wanted to chat a little bit about the way in which algorithmic decision making itself has changed. There was a time when algorithm decision making seemed to be almost like Amazon will tell you what books you should read, or Netflix will recommend which movies you should watch.
Yeah.
But because of AI, algorithmic decision making has become a lot more complex. And I was wondering if you could offer some examples, and what are some of the implications on the choices that we make or don't make as a result of this?
Yeah, algorithms pervade our lives, and sometimes we see it, like Amazon's recommendations, and sometimes we don't realize it. But they have a huge impact on decisions we make. On Amazon, for example, over a third of the choices that we make are influenced by algorithmic recommendations. People who bought this also bought this, people who viewed this eventually bought that, and so on. On Netflix, over 80% of the viewing activity is driven by algorithmic recommendations. They also drive decisions such as who we date and marry when you look at applications or apps like Tinder, which actually are apps where algorithms create most of the matches over there. They're also at the workplace. For example, you apply for a loan, mortgage approval decisions are made by algorithms increasingly. If you apply for a job, resume screening algorithms are deciding which ones to invite for an interview. And they're making life and death decisions as well. They're, for example, being used in the criminal justice system. In courtrooms in the US, there are algorithms that predict the likelihood that the defendant will reoffend so that judges can make sentencing decisions. In medicine, we're moving towards personalized medicine so that two people with the same symptoms might not get the same treatment. It might be customized based on their DNA profile. Algorithms, again, will guide the doctors on those decisions. And also we're moving, as AI has progressed and advanced, we're moving to a point where the algorithms don't merely offer decision support, they can function autonomously as well. And driverless cars are a great example of that, where we're trying to pretty much say you can automate the whole process and have algorithms function without a human making the final sort of decision.
So as more algorithms influence or make more and more decisions, is there anything like free will in the world anymore?
Well, so free will is an interesting concept. And for the most part, I used to think of free will in a very philosophical sense, right? And philosophers have argued we don't even have free will. But that was in a very different, very, as I said, philosophical interpretation. But I think we have a literal interpretation of free will now in the context of algorithms, which is, are you making the final choice? And I just said, a third of your choices are driven on Amazon by recommendations. 80% of viewing activities on Netflix are driven by algorithmic recommendations. At YouTube, 70% of the time people spend on YouTube is driven by algorithmic recommendations. So it doesn't feel like algorithms are merely recommending to us what we want and we make decisions. I mean, think about a search on Google. You take the most esoteric of search terms, like vintage toy model trains or something like that. You will still find hundreds of thousands, perhaps even millions of results for that search term. We might see less than 0.01% of those search results because rarely do we even cross page one. The algorithm has decided which pages we look at. So yes, they're making a lot of choices for us. So do we have free will? At some level, yes. But mostly I'm going to say we don't have the level of independent decision making that we think we do. Because most of us think we get these recommendations, we nod politely, and then we do what we want. But indeed, the algorithms are nudging us in very interesting ways. And I don't think we have the level of independent decision-making or choice that we think we do. Mostly that's a good thing in some ways because they're saving us time so we can focus on leisure instead of wasting our time sifting through lots of alternatives. But sometimes we become very passive about how we use algorithms, and becoming that passive about algorithm use can have consequences.
So let's talk a little bit about those consequences,
Okay.
especially unintended consequences.
Yes.
There's a fascinating part on your book about that. And how do design choices lead to unintended consequences? I was wondering if you could speak about that.
Yeah, so when I mention unintended consequences in the book, I'm referring to situations where, you're trying to optimize some aspect of a decision. And perhaps you manage to improve that really well, but then something else goes wrong. So an example might be that when Facebook was manually curating its trending stories through human editors, as an editor, you'll appreciate that. It's real work, right? And they had people doing that. But then Facebook was accused of having a left-leaning bias, that these editors were choosing left-leaning stories and curating those more often. So they said, algorithms can't be accused of a political bias. So they used an algorithm to curate this. They tested it for political bias. It did not have any political bias, but there's something else it did which they hadn't explicitly tested for, which is, as we know, it curated fake news stories and circulated them. So that's an example of unintended consequences. And algorithm design can drive that in many ways. I've done a lot of work on recommendation systems and how they influence the kinds of products we consume, the kinds of media we consume. And I've specifically studied two kinds of recommendation algorithms. One kind of algorithm is based on, it's like the Amazon people who bought this also bought this. So it's based on social curation. What are others consuming? The other kind of algorithm attempts to understand at a deep level what is it that I'm recommending, that the algorithm is recommending, and tries to find items that are very similar to the user's interest. An example of that would be Pandora. So Pandora's music recommendations are not people who like this song also like these other songs. Pandora actually has very detailed information, over 150 attributes for each song. Musical attributes like how rhythmic is the song, how much instrumentation is there in the music. And every time you say you like a song or you don't like a song, they look at the musical qualities of the song and then they adjust their recommendations based on other songs which have attributes similar to what you have. Now, I looked at both these designs and I looked at which design is more helpful in helping us find, let's say, indie songs or very novel and niche books or movies. And at the time we did the study, and this was some time back, the conventional wisdom was that all of these algorithms help in pushing the long tail, meaning these niche novel items or indie songs that nobody's heard of. And what I found was that these designs were very different. The algorithm that looks at what others are consuming, people who bought this also bought this. It has a popularity bias because it's trying to recommend stuff that others are consuming, and so it tends to lean towards popular items. And so it cannot truly recommend those hidden gems. But an algorithm like the Pandora algorithm doesn't have popularity as a basis for recommendation, so it tends to do better. And that's why what we've seen now is companies like Spotify, Netflix, and many others have changed the design of their algorithms. They've combined the two approaches. They've combined the social appeal of a system that looks at what others are consuming and the ability of the other design to surface hidden gems.
Interesting. Let's go now to the point you brought up earlier about algorithms going rogue.
Yes.
Why does that happen, and what can be done about it?
Yeah, if we look at, let me point to a couple examples of algorithms going rogue, and then we'll talk about why this happens.
Sure.
So I mentioned algorithms are used in courtrooms in the US in the criminal justice system. In 2016, there was a report or study done by ProPublica, which is a nonprofit organization. They looked at algorithms used in courtrooms, and they found that these algorithms have a race bias. Specifically, they found that these algorithms were twice as likely to falsely predict future criminality in a black defendant than a white defendant. And this was race bias in that algorithm. Late last year, Reuters carried a story about Amazon trying to use algorithms to screen job applications. And again, Amazon gets 1 million plus job applications. They hire hundreds of thousands of people, over the last few years. They've done that. It's hard to do that manually, and so you need algorithms to help automate some of this. But they found that the algorithms tended to have a gender bias. They tended to reject female applicants more often, even when the qualifications were similar. Now, Amazon ran the test and concluded and realized that they're a savvy company, so they decided not to roll this out. But there's probably many other companies that are using algorithms to screen resumes, and they might be prone to race bias, gender bias, and so on. So I mentioned two examples now, race bias, gender bias. I talked about fake news on Facebook. So there's many examples. In terms of why they go rogue, there's a couple reasons I can share. One is as we have gone from those old traditional algorithms where the programmer wrote up the algorithm end to end, and we've moved towards machine learning. We have created algorithms that are usually more resilient because these algorithms, can perform much better, but they're prone to biases that exist in the data. So if the data have biases, so for example, if you tell a resume screening algorithm, here's data on all those people who applied to our job, and here's the people we actually hired, and here are the people who we promoted. Now figure out who to invite for job interviews based on this data. The algorithm will observe that in the past you were rejecting more female applications or you were not promoting women at the workplace, and it'll tend to pick up that behavior. So it tends to pick that up. I think the other piece is that engineers in general tend to focus narrowly on one or two metrics. With a resume screening application, you will tend to measure the accuracy of your model, and if it's highly accurate, you'll roll it out. But you don't necessarily look at fairness and bias, or in Facebook's example, look at fake news and other possibilities as well.
What are some of the challenges involved in autonomous algorithms making decisions on our behalf?
Well, I think when you have autonomous algorithms making decision on our behalf, I think one of the big challenges is there is usually no human in the loop, so we lose control, and that is one challenge. And many studies show that when we have limited control, we are less likely to trust algorithms. And so that is one aspect that is challenging. The other piece about having autonomous algorithms is that, again, if there's a human in the loop, there's a greater chance that the user can detect certain problems. And the likelihood that problems get detected is therefore greater.
I'm really glad you brought up the point about trusting algorithms, because you tell this really fascinating story in the book about a patient who gets diagnosed with Tapanuli fever. I wonder if you could share that story with our audience and spell out some of the implications for trust in algorithms and what the implications are.
Yeah, the story that I share is that of a patient walking into a doctor's office, and the patient feels fine and healthy, and the patient and doctor are joking around, and the doctor eventually picks up the pathology report, and he suddenly looks very serious, and he says or informs the patient that, I'm sorry to let you know that you have Tapanuli fever. And the patient hasn't heard of Tapanuli fever. And he asks, what exactly is it? And so the doctor says it's a very rare disease, and it's known to be fatal. And so I suggest that you have this tablet, and it will reduce the chance that you will have any problems. And he says, here, you take this 3 times a day, and then you go about your life. And I ask my readers if, that story is something that if they were the patient, they would feel comfortable in that situation. Here's a disease you know nothing about, and here's a solution you know nothing about. And the doctor has given you the choice and told you to go ahead, but not given you very many details. And with that, I pose the question, if an algorithm were to, again, make this recommendation that you have this rare disease and we want you to take this medication without any information, would you? And of course, Mukul, you've read the book, so you know Tapanuli fever is not a real disease. I'm a fan of Sherlock Holmes. I used to read it a lot as a kid, and it's a disease in one of the Sherlock Holmes stories. And, that inspired me to consider this, because even in the original Sherlock Holmes story, it turns out that the person who has Tapanuli fever doesn't actually have it. But setting that aside, it kind of brings up this question of transparency. Are we willing to trust decisions when we don't have information about why a certain decision was made the way it was? And what I highlight is sometimes we're seeking more transparency from algorithms than humans. But in practice, lots of companies are imposing algorithmic decisions on us without any information about why these decisions are being made. And are we fine with that? And a lot of research shows that we're not fine with that. Research, for example, that one PhD student, then a PhD student at Stanford, looked at an algorithm that would compute grades for students. And how did they do when they just got their score versus they got their score with an explanation? And as you expect, when they have an explanation, they trust it more. Then why is it that in the real world, there's a lot of algorithms making decisions for us or about us, and we have no transparency about those decisions? And so I advocate that we need a certain level of transparency with regard to, for example, what kinds of data were used to make the decision. So, for example, if we applied for a loan and the loan was rejected, we would like to know why that was the case. If you applied for a job and it was rejected, it would be helpful to know that the algorithm not only evaluated what you submitted as part of your job application, but also looked at your social media posts. And so transparency regarding what data was considered, what were the key factors that drove a decision is important.
So towards the end of the book, you recommend an algorithmic Bill of Rights. What exactly is that, and why is it necessary?
So the algorithmic Bill of Rights is a concept that I borrowed from the Bill of Rights in the U.S. Constitution. And the history of the Bill of Rights is that when the Founding Fathers were setting up or drafting the Constitution, some people were worried that we're creating a very powerful government here in the US. And the Bill of Rights was created as a way to protect citizens. Now today we are in a situation where there's a lot of talk about powerful tech companies. Everywhere you see there's news stories, big tech companies, and what are we going to do about them? And so there's a sense that, again, consumers need certain protections. And so the Bill of Rights is targeted at that. But before I talk about the Bill of Rights, one aspect related to the Bill of Rights I do want to address is that a lot of consumers feel that they're helpless against big tech and against algorithms deployed by big tech. And personally, I feel that consumers do have some power. And that power is in terms of our knowledge, our votes, and our dollars. Knowledge is about, we shouldn't be passive users of technology. We should be active and deliberate about it. We should know how it's changing decisions we are making or others are making about us. And at some level, it seems like, knowledge is fine, but what can I do with that knowledge? But I mean, look at how Facebook is changing their product design today. And that changes, support for encryption and so on is because of push from the users. And it shows that when users complain, changes do happen. Votes are another aspect of that. And votes are all about, us being aware of which elected representatives understand the nuances of algorithms and the challenges and how to regulate them. And it's about voting for them, right? And the question is, how are these regulators going to protect us? And that's where the Bill of Rights comes in. And the Bill of Rights I propose has a few key pillars. One pillar is transparency. Transparency with regard to the data used to make decisions and with regard to the underlying decision itself. What were the most important factors that led to a certain decision? Today, Europe's GDPR actually has certain provisions like right to explanations and information on the data that companies are using. And so I think some of that transparency is needed, and companies should provide that. Another pillar in my Bill of Rights is the idea of some user control, that we cannot be in an environment where we have no control over the technology. We should, for example, be able to, with a simple instruction, tell Alexa, you're not listening to any conversation in the house until I instruct you that it's allowed, right? There's no such provision. We're told that the system is not listening, but then we're also hearing from others that there are instances where it listens even when you're not actually saying Alexa and giving an instruction. And that control is very important. If you look at Facebook, the false news issue, 2 years back, there was no way for users to alert Facebook's algorithm and say, this post in my newsfeed is false news, even though users were seeing false news in their newsfeed. Even today, with just 2 clicks, you can let Facebook know that a certain news post in your feed is either offensive or it has false news. And that feedback is so important for the algorithm to now correct itself. And previously, users had no way, even though you're observing problems, no way of informing the algorithm or helping the algorithm course correct. So some level of user control is also another pillar I propose. And lastly, I have been advocating this idea that companies should formally audit algorithms before they deploy them, especially in socially consequential settings. Not every algorithm needs to be audited, but algorithms in socially consequential settings like recruiting need to go through an audit process. And that audit process can be done by an internal team. Or it could be outsiders, but it's got to be done by a team that is independent of the team that developed the algorithm. And the audit process is going to be important because it will help ensure that somebody has looked at things beyond, say, the prediction accuracy of the model. They've looked at things like privacy. They've looked at things like bias and fairness. And so that will help curb some of these problems with algorithmic decisions.
So we could keep talking about this all day. I've sort of come to the end of the list of questions I had for you. Are there any points that you would like to emphasize that I haven't asked about?
One of the key messages I want to share with people, even though I'm sharing many of the challenges with algorithms in my book, is that I'm not an algorithm skeptic. I'm actually a believer in algorithms, and I don't want any listener or viewer or reader to leave this becoming wary of technology. I think the message is not be wary, but the message is engage more actively and more deliberately and be part of the process of influencing how these technologies develop. So, and the reason I say that is that studies show that algorithms on average are less biased than human beings. So if we say we don't want algorithms, we need to ask what's the alternative? And the alternative is biased. Furthermore, my contention is that it is easier in the long run to fix algorithm bias than it is to fix human bias. But the challenge with algorithm bias is just that bias scales in a way human bias does not scale. And what I mean by that is that a prejudiced judge can impact the lives of maybe 200, 300 people. But an algorithm used in all the courtrooms in a country or across the world can influence the lives of hundreds of thousands or even millions of people. Similarly, a biased recruiter can affect the lives of hundreds of people, but a biased recruiting algorithm can affect the lives of millions of people. So it's the scale we worry about, and that's why we need to take the issue seriously. But the message mostly is, I think we're going to a world where these algorithms will help us make better decisions, and we'll have growing pains along the way. And the few examples I mentioned, I think, is only just the beginning. We'll hear many more. And we should engage actively now to minimize those incidences.
Karthik, thank you so much for speaking with Knowledge at Wharton.
Thank you for having me. It's been a great pleasure.
For more insight from Knowledge at Wharton, please visit knowledge.wharton.upenn.edu.